Gearheads. In this video, I'm going to show you how to figure out the required wiring, pinout, and configuration in order to connect your SEGGER Flasher in-system programmer to a target device. For links and hints, please see the description below. If you're enjoying this video, please like and subscribe. Let's get started. The first step is to check if your target device is supported by the SEGGER Flasher, and if so, to what extent. In order to do that, go to segger.com, hover over Products, and then click on Program. Click on Supported Devices in the page menu. Type in the part number of the target device you need to program and hit Enter or click Submit. If you see your target device in the list and you have a check mark in the column for your Flasher model, you're off to a good start. Note that for a lot of devices, especially from the major manufacturers, SEGGER has created knowledge base pages for the associated device families. If there is no knowledge base page for your device, skip this step. You can click on this link to get to the knowledge base page to see additional important information about the provided support. For example, you can see which internal flashbangs the Flasher is able to program on your device. You can also see if indirect programming of external serial NOR flash, like SPI flash, that might be connected to your device is supported, and if so, in which configurations. Note that if there is no mention of SPI flash here, then this usually means that indirect programming of externally connected SPI flash is not supported for this device, at least not yet. If this is something you need, or if an internal flashbang you need to program is not listed, you need to contact SEGGER. As an aside, the information on these device family knowledge base pages is very useful overall, so keep them in mind. After you have established that your device is sufficiently supported, make sure you download and install the latest Flasher software and documentation pack from the SEGGER website. Under Downloads, Flasher. This software pack gets updated frequently, so if you are working with an older version of the Flasher software pack, it might not yet support your target device. Therefore, make sure you're always working with the latest version. On the left, you can find the key contents of the Flasher software pack, as well as the release notes, which can come in handy sometimes. If you would like to be notified whenever an updated Flasher software pack has been released, you can subscribe to the Flasher software update notifications here. On the right, you can see the available installers. The Flasher software pack is currently available for 5 different combinations of host OSs and host architectures, so make sure you download the correct installer for your host computer. Next, check the documentation, specification, or schematics for your target board and figure out the intended way of connecting to the target device in order to program it. Note that many circuit boards these days have multiple devices on them that need to be programmed. Make sure you identify the correct access point for each of them so you don't accidentally try to program the wrong target device on the board. One very common way of programming the target device is via a debug interface like SWD, JTAG, or CJTAG. For Arm Cortex-based devices, the most common debug connector carrying these debug interfaces is the 10-pin 0.05-inch connector as originally defined by Arm. This is the associated pinout using SEGGER Flasher terminology. Pin 7 is supposed to be missing in order to accept a key from the cable to be plugged in, but very often you see this connector having all 10 pins. Pin 7 is just not connected in this case. Make sure your target board feeds the target device's voltage supply level back to the Flasher on pin 1, which is the target reference voltage pin called VTREF. This sometimes misunderstood pin is an input pin used by the Flasher to check if the target board has power, to create the logic level reference for the input comparators, and to control the output logic levels to the target device. So this is quite important. Note that there is a way to configure the Flasher to assume a certain fixed target voltage level and ignore what it measures on the VTREF pin. This is a very helpful workaround just in case the VTREF pin is not connected in your design. If your target board has the 10-pin Arm Cortex Debug connector, then the SEGGER 9-pin Cortex-M adapter will allow the SEGGER Flasher to access the target device via SWD, JTAG, or CJTAG, depending on what your target device/target board combination supports. Connect the 9-pin Cortex-M adapter to the flasher as well as the debug connector on the target board. Sometimes the connector is keyed, sometimes it's not. If it is not keyed, watch out for the correct orientation. The red wire or the ribbon cable needs to connect to pin 1 of the connector. Also make sure that the cable header covers both rows of the connector. Sometimes you also see a 20-pin version of this debug connector, which was also specified by ARM. The associated pinout from a SEGGER Flasher reference point is shown here. Note that pins 1 through 10 correspond exactly to the 10-pin version we just talked about. The full version of this connector also carries a trace clock pin and 4 trace data pins, which are used for instruction tracing during advanced debugging, for example using a SEGGER J-Trace probe. But the SEGGER Flasher does not use these pins, so it will leave them alone. Again, pin 7 on this connector is supposed to be missing in order to accept a key from the cable to be plugged in, but very often you see this connector with all 20 pins. Note that when using this connector, you have the option to configure the flasher to power the target board up to 400 milliamps using pin 11 and/or pin 13 if your target board is designed accordingly. The flasher is only able to output 5 volts on these 2 pins. However, SEGGER offers various target adapters that allow you to supply your target board with voltages other than 5 volts if required. Of course, you can also apply power directly to your target board and not power the board via the flasher. No matter how you are powering your target board, make sure your target board feeds the target device's voltage supply level back to the flasher on pin 1, the VTREF pin. If your target board has the 20-pin Arm Cortex Debug Trace connector, you can connect to the target device via SWD, JTAG, or CJTAG using the SEGGER 19-pin Cortex-M adapter. Connect the 19-pin Cortex-M adapter to the flasher as well as the debug and trace connector on the target board. Again, if the connector is not keyed, watch out for the correct orientation. Make sure the red wire of the ribbon cable is connected to pin 1 of the connector, and that the cable header covers both rows of the connector. To save cost and board space, some target boards don't have an actual connector for debug access. Instead, these boards may have a footprint for a needle adapter. This is the associated pinout using SEGGER Flasher terminology. As before, watch out for the VTREF pin and note the optional 5-volt supply pin. If your target board has a footprint like this, the SEGGER 10-pin needle adapter will allow the SEGGER Flasher to connect to the target device via SWD, JTAG, or CJTAG. The 3 locating pins ensure that the adapter cannot be connected to the PCB the wrong way. In addition, the 2 clips on each side of the connector guarantee a stable and secure contact between the pins and the PCB. If your PCB doesn't have the holes for the clips, you'll need to cut them off and hold down the needle adapter by hand during programming. There is also an even smaller 6-pin version of this type of connection. The associated pinout is shown here. Note that there's no 5-volt supply pin in the 6-pin version. Also note that a regular JTAG connection to the target device is not possible using the 6-pin adapter. If your target board has a footprint like this, the SEGGER's 6-pin needle adapter will make sure the SEGGER Flasher can connect to the target device via SWD or CJTAG. Just like with the 10-pin version, the 3 locating pins ensure that the adapter cannot be connected to the PCB the wrong way. Some target boards still have an older 20-pin 0.1-inch pitch debug connector as specified by ARM. This is the associated pinout using SEGGER Flasher terminology. If your target board has a header like this, then you can directly connect the SEGGER Flasher to your target board using the included 20-pin ribbon cable. If your target board does not offer any of these described standard ways to connect to your target device, then browse the large selection of SEGGER programming adapters to see if one of them fits your needs. To find the programming adapters, go to segger.com, hover over Products, and select Flasher Adapters. You can scroll through the page to see the various adapters. You can also hover over Accessories, Adapters for a list of the available adapters. You will find adapters that are specific to devices from certain silicon vendors like TI, Renesas, Infineon, Microchip, etc. Others adapt to different kinds of target connector form factors or pinouts. Some adapters provide different options to supply power to the target board, smoothen signals, or provide measurement capabilities. Maybe the most universal adapter is the so-called flying wire adapter. It allows connecting the flasher to target boards via individual wires. This is especially useful when connecting to boards without a dedicated debug connector, or to prototype hardware where no final connector is decided yet. In the SEGGER knowledge base, there is additional information about the pinout of the 20-pin connector on the flasher. This page has the flasher pinout for JTAG, including a description for the individual pins. Note that the flasher is also able to program RISC-V based devices via JTAG, and even FPGAs and CPLDs, also via JTAG, thanks to the new Flasher Bitstreamer tool. This page shows the flasher pinout for SWD. Links to both pages can be found in the description below. This other page also has the pinout for CJTAG, SPI, and QSPI, as well as target board design recommendations. It is titled 20-pin J-Link connector, but is also valid for the flasher. The link to this page can be found in the description below. Note that the pinouts that are shown are valid when looking straight at the 20-pin connector on the flasher. One more thing related to the flasher connector pinout is worth mentioning. The SEGGER Flasher Hub and the Flasher ATE2 are able to communicate with a UART on the target device via the UART port feature. This can be helpful for exchanging information with the target device after it was programmed. For example, for running various tests on the target, or for writing and reading calibration data on the target. With the UART port enabled, the target interface of the respective flasher compact module looks like this. If you want to use the UART port feature after programming, the target board needs to be designed in such a way that the receive pin of one of the UARTs on the target device is routed to pin 5 of the flasher, and the transmit pin of the same UART is routed to pin 17 of the flasher. Note that this is the same pinout as when using the virtual COM port on a SEGGER J-Link debug probe to communicate between the host computer and a UART on the target MCU. Also note that on the Flasher ATE2, the 5-volt supply pins cannot be used to supply power to targets. More details can be found on this page. You can find the link to this page in the description below. After you have identified the correct way to connect the flasher to your target board, you can use the SEGGER U-Flash software from the Flasher software pack to create a project to set up your flasher for standalone programming. This involves selecting your device, adding the data file to be programmed, configuring common and device-specific options, selecting your flasher, and downloading the project files to the flasher. But what if your target device is not ARM or RISC-V based, or needs to be programmed via a different serial interface, for example UART, SPI, I2C, or some proprietary protocol? For these cases, U-Flash has a great feature that lets you see the wiring diagram for the selected target device and the selected target interface. Let's say we need to program a Renesas RX device via its bootloader, which communicates via UART. Select the desired RX target device in U-Flash, and then verify the target interface in the project settings. Then click the Show Wiring button. U-Flash will show you how the target device needs to be connected in order to be programmed properly. Note that supplying power to the target via the pin 19 of the flasher connector is optional. Of course, you can also power your target board separately. Just make sure you feed the target MCU's voltage supply level back to the flasher on pin 1 of the flasher connector, the VT-Ref pin, as mentioned earlier. Note that the wiring diagrams in U-Flash not only work for MCUs, but also for serial external memory devices that have their own programming header. For example, we can select a SPI flash device and see the wiring required to program it. If you can't find your target device in U-Flash, or if it is listed but not with the correct target interface, open the SEGGER J-Flash software from the Flasher software pack and see if you can find it there. Coming back to the Renesas RX example, if you need to program that RX device via the JTAG or FINE interface instead of the UART, open J-Flash, create a new project for the RX device, and then select the JTAG or FINE interface. Just like U-Flash, J-Flash also lets you prepare your flasher for standalone programming. But it is limited to target connection via debug interfaces like SWD or JTAG, while U-Flash also supports serial interfaces like UART, SPI, or I2C, as well as specialized on-chip bootloaders. If you have a serial NOR flash like a QSPI flash that you need to program directly via SPI, meaning without an MCU in between, and you can't find it in U-Flash, be sure to check out the SEGGER J-Flash SPI tool. Just like J-Flash and U-Flash, J-Flash SPI can also set up the flasher for standalone programming of those devices. Since the flasher communicates directly with the QSPI flash, even flash memories connected to MCUs that are not supported by flasher can be programmed. The J-Flash SPI webpage shows the flasher 20-pin connector pinouts that apply to SPI and QSPI flashes, as well as the pinout of the footprint on the target board when using the 10-pin needle adapter. The list of supported SPI flash memories can be found on this page. Note that the SEGGER Flasher cannot program target devices via more complex serial interfaces like LIN, CAN, or USB. And there you have it, fellow embedded heads. Now you know how to connect your SEGGER Flasher in-system programmer to a target device. Because SEGGER Flashers are so flexible, and due to the large variety of target devices that can be programmed, we were not able to cover all use cases in this video. However, we still hope you found it useful. So if you enjoyed this video, please like and subscribe. Please also feel free to leave comments below. Thanks for watching.